make sure that happened. Okay, we're good to go. I'll take a minute and introduce some folks. At Hempstead Public Library, we have Stephanie Crocco. So if there's folks there, just, hey, Stephanie, I'm sure you know her. And then at Georgetown Public Library, we have Rachel Culver. Hey.
And Cole, we have quite a few people here, but I'm just going to keep the video off. But
sounds good.
All right.
Thank you very much. Great. So I'm going to dive in here. So again, welcome. This is just to kind of give you a preview of what we're in for today. So I'll do some introducing, a few just housekeeping things, and then some information about the James Webb Space Telescope, and then some at least one activity, and there's one to take home if you like. So let's move on here. So again, my name is Cole Beatty. I am a rising junior at Old Dominion University in Norfolk, Virginia. I'm a cyber operations major, which is a computer science-based cybersecurity degree that ODU offers here in Norfolk. And I'm very excited to finish this degree and see what the world has to offer for me. You may think, whoa, so we're talking about space stuff and here's a computer guy. But you'd be surprised at how much overlap there is. And for myself, I am just a lifelong space and science lover. Anytime the Discovery Channel had a space documentary on it, I was watching it growing up, like I read all the books. I really like learning about space. So I hope I can bring some of my love for space to the rest of you. Again, we have Rachel.
I never went to.
Again, we've got Rachel Culver at Georgetown and Stephanie Crocco at Hempstead, and a couple people I did want to mention who are not named on this slide, but in the session we have with us Dr. Friyanya Pursardar, who is the faculty advisor for the NASA at My Library program here at ODU. There she is.
Yeah. Hi, everyone. Welcome.
And then this person is not on with us today, but I did want to thank and mention Stephanie Vero Fields. She is the coordinator at NASA at My Library, who oversees all of these programs that are happening all over the country throughout the rest of this year. So I want to thank everyone I just mentioned for all their help. I did want to mention a few housekeeping things. For those of you in person at the libraries, the librarians may be coming around taking photos. If you want to take photos yourself, please feel free. But these photos may get used for NASA in-house things, and they need your permission to use your face, especially if your children, if you have children and their faces appear in these photos. So the librarian should have some of these photo release forms, and we can get them to you if they're not around. But we'll collect them at the end of the presentation, and yeah, it'll be great. There is a hashtag, so if you do take some photos today and you're okay with NASA using them or whatever, there's the hashtag here, hashtag STEM in live, so that's STEM in library. So feel free to take photos and tag them up. We'll find them and all have fun. So without any further administrative hubbub, let's dive in. So we're here to talk about the James Webb Space Telescope, the 5 W's. Who knows what the 5 W's are? Feel free, anybody. So let's say who is the first W, right? So if who, what, where, when, why, people have heard this, right? The 5 W's, who, what, where, when, why. So that's what I thought I would do today. So today I wanted to start with who. And who is a weird question, right? We're talking about who built it or who is James Webb. So on the left side of your screen here, here's a nice, lovely drawing of the telescope, sort of out floating in space. I was actually going to turn my camera off. Whoop. Come on now. There we go. So that I'm not taking up the screen. Anyway, sorry. So who built it? Let's answer that question. Of course, NASA was involved. But there were also some partners with other nations and government agencies all over the world, including the European Space Agency here in the middle, ESA, and the Canadian Space Agency, the CSA. Over here, it's ASC because they have two languages in Canada, English and French. So French acronyms are usually just the reverse of the English ones, but this is the Canadian Space Agency. And they helped put all this together and get it launched to where it lives in space now and is getting very close to being ready to doing some real science. Who was James Webb? Well, I've got a photo of him here. James Webb was the second administrator of NASA in the 1960s during the Apollo program. The Apollo program, if you don't know, was the name of the several, I think it was about 12 missions that put human beings on the moon. And James Webb was not the administrator when we finally did land a person on the moon in the late 1960s, but he was in charge of NASA the whole time they worked up to putting a man on the moon. So NASA and everybody decided they would honor his memory and his legacy and his contribution to space exploration by giving the telescope his name. So that's why it's called the James Webb Telescope. So let's move on to what? What is the James Webb Space Telescope? Well, it is a space telescope, which are words that you know individually, space and telescope. So it's simply just a telescope in space. And the reason we put it in space is because mostly it's easier to see things in space. There's not atmosphere. You can point at the same thing for a really long time, which you need sometimes with these very complicated telescopes. And so here on the right, we've got an image, looks like a computer rendering of this telescope. And you see these honeycombs, right? There are 18 of them. They're honeycomb or hexagonal shaped, six-sided, and there are 18 of them. And what they do is they bounce light from very deep space over to this mirror here, and then into the sensors for processing and transmission to Earth for analysis, where we can do more science. I'll talk a little more about the sensors here, why they're infrared and why they need to be. And then these layers you can see here are sun shielding. The telescope needs to be very, very cold to operate. And the way it's positioned, space is going to be like on this side of the sun shield, and the sun and Earth will be behind it over here. So if the sun is shining on the space telescope, it's going to get very hot, and we need it to be very cold. So that's why they made these very impressive sun shields here. And they're all very large. Each of these is the size of a tennis court. Does anyone know of any other space telescopes? A very famous one from when I was young, when I was in elementary school back in the 90s, was the Hubble Space Telescope. And I'm still blown away by the images we get from it. So James Webb is the successor to Hubble in a lot of ways, because Hubble is, you know, we can't keep a space telescope in space forever. We've got to replace it every now and then. People don't drive the same car their whole lives. Most people. You have to get new things every now and then. So this is the new space telescope. And I talked about the mirrors earlier. So here is sort of a diagram showing how big the mirrors are, right? Over here on the left, we've got a nice young lady, and she's pointing at the mirror for the Hubble telescope, which I was just talking about. And it's kind of similar. It bounces light around, and then the sensor goes in this hole. But this is the size of the mirror. And the diameter, so all the way across, is 2.4 meters, or about 6 feet, 6 or 7 feet. Well, the James Webb Space Telescope is 6.5 meters from this side to this side. That's almost 3 times as much, about 20 feet across. And you can see this lady is still over here. Look how tiny she is compared to the hexagonal mirrors. So it's quite a large telescope that we put in. It's much larger. It's able to see deeper and see more things than Hubble. So where has a number of answers. I'll start with where did it launch from? It launched from a country in South America called French Guiana. And if you can see my mouse, so here's the US, right? Florida, Cuba, and Jamaica, and Haiti. And then down here is South America. And somewhere along this coast is French Guiana. And the reason we launched it from French Guiana is because it has to go very, very far in space and takes a lot of energy. So the closer we can launch to the equator, we're able to use some of the Earth's own spinning to impart energy to the rocket that's going to take it out. So if we had launched it, say, from Florida, where Cape Canaveral is, we would have had to put a little more fuel in it because it would have taken more energy to get to where it is now. But we were able, by traveling south, to get a little more energy. I have a video prepared. This is from the launch on Christmas Day last year in 2021. It's about 40 seconds long, but I always find rocket launches really exciting. So I thought I'd play this for you. So here we go.
Start. Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching the hole through the clouds, 20 seconds into the flight, good pitch program reported. Vehicle performance is nominal. The Ariane 5 rocket continues.
I just think that's great. I mean, he said 20 seconds in and it was so tiny. It's just such a powerful rocket. I'm always so impressed by rocket launches. So where is it now? I showed you already. So here's a diagram showing the Earth, and then the Hubble telescope, the moon, and the position of the James Webb Space Telescope. Now, these aren't to scale, obviously. They'd be very tiny, and the screen's not wide enough to show everything properly, but this will do. So I wanted to talk about some of these distances, right? Because you hear large numbers like, oh, the moon is 384,000 kilometers away, or James Webb is 1.5 million kilometers away, but we don't really deal with numbers that large in our own daily lives. So I'm going to frame this in terms of how long it would take to drive. So we see here, we've got the Hubble telescope, and they're telling us it's 570 kilometers, which is about 350 miles. So driving at around 60 miles an hour, it would take you about 6 hours to drive to the Hubble Space Telescope, assuming you could drive straight up to space and meet it in space. The moon orbits at 384,000 kilometers. So the Earth is 40,000 kilometers around. If you started at the equator and were able to drive over ocean and land, don't worry about that. But if you just started driving all the way around the Earth, around the equator, it would take about it's about 40,000 kilometers. So to get to the moon, you would have to drive around the Earth around 10 times. That's a really long way. That's just the moon. Well, the James Webb Space Telescope is out here at a point called L2, which means Lagrange 2, or libration sometimes, but mostly Lagrange. Lagrange 2 is 1.5 million kilometers away, which is 40 times farther away. It would take just so long to drive. So it's very, very, very far away. We haven't actually sent human beings out this far, which is really exciting, I think. So what is L2? And why L2? L2 is a really interesting point in any two bodies that orbit each other, right? We have here a diagram on the left showing us the sun, and these are gravity waves, right? If you've seen a topographic map, this is similar, right? So gravity is strongest where the lines are closest together and not as strong where they're spaced further apart. So as you see, when you get near into the sun, they're getting closer and closer and closer. The gravity is getting stronger. As we get near to the earth, they're getting closer and closer and closer. Well, believe it or not, there are, between any two bodies, there are 5 points. I've only shown 3 here, but there are 5. The others are way out above on top and way below bottom. We don't need those. But these 3 points are points where the gravity of the sun and the gravity of the earth more or less cancel out. So it's easy to keep things there. I'll let my cat out real quick. So sorry. Right, so L1, L2, L3, L4 not shown, and L5 not shown are all places near Earth or in the Sun-Earth system where, the gravity more or less cancels out. So it's easy to keep things in these spots. Now, we're interested with the James Webb Space Telescope in very deep space, the early history of the universe, formations of early galaxies, that kinds of thing. So it wouldn't do to put the telescope here because the sun is there. We'd need much more intense shielding. But as you can see here, like the Earth's shadow kind of reaches, I don't know if you can see it on your screen, but I can certainly see it here. There's the cone of the Earth's shadow that extends all the way out to here. So the telescope is in the Earth's shadow, way far out in space where it's already really cold, shielded from the sun by the Earth somewhat. So this makes more sense. We don't want to put it on the other side of the sun because then it would be really difficult to communicate back to Earth. We have the whole sun in the way, right? It's very bright, very noisy. So that's why they chose L2. And all of space is out this way. The rest of the solar system, the rest of the galaxy, all of it. And we get, as Earth and L2 move through the orbit, right? We get all of it. In a year, we'll have seen all of space with this telescope. So next up is when. I'm not going to read each of these to you. You can read yourself, but I really wanted to just point out how long it took to get this telescope into space. We see here, 1996 is when they started this project under the name of the Next Generation Space Telescope. Remember earlier I spoke about the Hubble telescope and how James Webb is the successor. So this is the next one. Went through a couple name changes. You can see that they changed the mirror size. We got ESA on board in 2007. Somebody tried to cancel it. How dare they? It was finally finished in 2016, and then it took 5 years to put everything together and test it and make sure everything is working correctly in the way we want to. Load it on the rocket, get everything to South America, French Guiana, and finally launch it in 2021, as we saw a couple minutes ago. So finally, why? Why do we need a new telescope? As I said, it's replacing Hubble. Not exactly one-to-one replacement. The James Webb Space Telescope operates a little differently than Hubble. Hubble uses visible light, which is to say the light you and I are seeing right now, human beings. But James Webb Space Telescope operates mostly in infrared, which is not very visible, but it is one of the types of light which carries heat, which is why it needs all this shielding. The thing needs to be very cold so it can distinguish between the very faint heat of these very old and distant stars. That's why this telescope needs to be very, very cold. And why it needs to be so far away, because space is very cold. Right, so we're replacing Hubble with James Webb. And James Webb can see different things than Hubble. So that's kind of why we're doing that. we just kind of went over why it's at L2. L2 is, again, very, very far out, 1.5 million kilometers, where it's very cold and very dark, which is all the conditions the telescope needs in order to operate the sensors that do all the science. There's 4 different types of infrared sensors, and they all need to be very cold and very dark. So that's why they sent it to L2. And L2 also handily, we don't get light pollution from the sun. We don't get like radio broadcasts or anything like that from those things. It's all shielded behind the like interference from the sun is shielded by the earth. Interference from the earth is also shielded out by the sun shield. So it's inconvenient for humans to get to, but super convenient for this telescope to be at L2. So also, why do this at all? What's to be gained by launching this very expensive telescope out so far from the Earth? Well, the 4 stated objectives of the James Webb mission are to learn more about the early universe, number 1. Number 2, I really should have put this on the screen, huh? Number 2 is to study the formation of galaxies and the evolution of galaxies, how they change over time. The 3rd mission is to understand the formation of stars and planets, how stars collapse from dust and how planets form around stars. And also to seek the origins of life. It's human nature to wonder whether we're alone in the universe. And we can only know what we know here on Earth about how life exists, but we can seek for things we know about life on Earth in other planets, other star systems. So hopefully we see something that lets us know we're not just here alone. But maybe the biggest question as to why we need to replace Hubble, why we're doing all this is, I can't say. I'll just show you a photo. So I've got 2 photos here. On the left, I should say these are photos taken from 2 different space telescopes of the same region of the sky. On the left is from the Spitzer Space Telescope. I'm not terribly familiar, but I do know that IR stands for infrared. So it's similar to Webb in that it's looking in the infrared part of the visible light spectrum. But just look how much clearer the photo is from Webb than from Spitzer. And I believe the photo on the right was taken during the alignment. So this is the alignment phase, right? The telescope had to get where it was going, unfold all of its mirrors, boot everything up and align the mirrors so we can get one beautiful image like this. And just look, I mean, there's so many more stars. You can see with much more clarity all of this space dust. Here's a whole galaxy right here. That's probably Andromeda. I think this picture speaks for itself. There's so much more information in the photo on the right than in the photo on the left. And that means there's just that much more to learn when the scientists start studying the things coming back from Webb when it's fully operational and online. So that's most of the program so far. I just wanted to give you sort of a brief overview about James Webb. I did want to mention that the first full color images we're expecting from James Webb are on the 12th of July, so next month. So, I mean, I'm sure you'll see it on Twitter or Reddit or whatever you do. But I'm really looking forward to that. And I hope you do too. So I wanted to ask, and if the folks at the libraries could help us out, if anyone has any questions at this point, I'm happy to answer a few. If I can.
Hi, so we have a question here at Georgetown.
Sure.
So would you like to?
I was wondering that nothing in space is like completely stationary. So like what exactly is the motion of the telescope?
You get that?
I didn't quite, I think it has something to do with, no, I didn't quite hear it all the way.
So nothing in space is stationary. So what exactly is the motion of the James Webb Telescope?
So let's back up a little bit. You're right. Nothing in space is stationary, right? When we talk about things being stationary, it's relative to something else. But everything is moving. So you can think of L2 as sort of a sphere where there's no gravity, right? I mentioned how the sun and the Earth's gravity cancels out. So there's like another invisible, no gravity planet just kind of hanging out here. And Webb is orbiting that. So this whole system, right, Earth and L2 moves along the orbit of the Earth around the sun. So its position relative to Earth is more or less the same, right? It's just hanging out here, but this position, the Earth, L2, L1, L3, L4, and L5 are all moving in their own orbit. See here, there's Earth's orbit in this light blue here, and then we've got L2 tracking on the yellow line, and L3 over here is on the blue line too. So as Earth moves through its own orbit around the sun, L2 follows it, and all the other Lagrange points follow it too. So relative to the Earth, James Webb is in the same position. It doesn't matter where the Earth is relative to the sun. James Webb itself is going to be, on the far side, on the not sun side of the Earth, about 1.5 million kilometers away. Did that answer your question?
Yes, it did. Thank
Excellent.
you so much.
Let's take 3 more questions, and then I think we'll move on to the activity, if there are 3 questions. Sorry. Anyone online have any questions? Okay, great. Well, if anyone online or anyone at the libraries has one, feel free to drop it in the chat. But what I think we'll do now is I've prepared an activity. So I'm going to stop the presentation and hop over to this. So as I mentioned earlier, my major at school is sort of computer programming oriented. So I wanted to tie this project into computer science. And the way I want to do that is by thinking about how far away the Space Telescope is. It's very far away. I think I said it's farther than we've ever sent human beings. So we can't send people there to operate it. We would need a spacecraft like no one has ever built to send human beings to where there is the telescope. I was hoping that would go away. So we have to operate it remotely, and sometimes it's so far away, it takes a long time for the signal to reach. So it has to operate by itself remotely. And that's where computer programming comes in. So I wanted to take some time here and show you one of the most popular, if you're not familiar with programming, this is an easy one to learn. It's called Python. And the reason it's popular for first-time learners is because it's very simple. Here's a little program. Well, let me show you this. It's called online-python.com. I found it by just Googling online Python. But I really like this one for this purpose because it's very simple. They call it an IDE. And all that means is you have everything you need right here to write the program and then run the program. And so what this program does is it asks for one number. So let's say 3. And the next number, 50. And we add them together and it says the sum. So all it does is just add them together, right? That's what this program does. You can hear it says enter the first number, enter the second number, and then we see sort of the things we see down here, right? Sum of doot. We're not going to dig too deep into this. I just kind of wanted to demonstrate what's going on. Let me I can get rid of that. That is unfortunate. Okay, so when I say Python is simple to learn, let me show you this. Let me copy this. And I will put it in here. Just look. Can everyone still read that? If it's that small, just let me know if I need to make it bigger, and I will. So in programming, traditionally, the first thing anyone learns how to do is to prevent a very nerdy phrase called hello world to the screen. So I've got 3 examples here in 3 different programming languages of how to do that in each language. The first one here, we've got Python, and you can see it's really just print, and then we've got open parenthesis, we've got hello world surrounded in quotation marks, and then we close the parenthesis. And that's it. If we ran just that much, right? If we do just this much, hello world. Excellent. Pretty simple. These other ones are a little more complicated. This is another very popular programming language called Java. And here we see something similar, right? Up here it was print. And then down here we've got print ln. That means print line. So that means it's not important. Print a line to the screen, and the line says hello world, right? But we have all of this other stuff we had to do before we could even get to print line. And if you're like me, and you're learning the very first thing is hello world, and someone says, oh, well, first you need this and this and this, I'm going to get really distracted wondering what all these things mean. So I think for learning purposes, that's why Python has an edge over Java, because I wanted to print, all I had to do was tell it to print. But in Java, I have to do all this extra stuff that I don't really understand at this point. So I'm not, right now, for learning purposes, not really sold on Java. So goodbye, Java. Here's another very popular programming language called C++. And all of these things are things you have to do. We don't have print line. This is I'm not going to explain why, but this is what does the same thing. If I ran this in a C++ interpreter, you would get this same line exactly the same with all of this stuff. Again, I would get really bogged down. What does this mean? What does this mean? Why are we doing all these things? So really, right now, I just want to print. And I showed you, boom. Do we have everyone? Like, are there any questions so far? I just really wanted to use Python and explain why I wanted Python for this demonstration. Great. So we've printed hello world. So just a definition, right? In school, we're learning about English or Spanish or German or any kind of language. There are parts of speech, right? We've learned about nouns, we've learned about verbs, we've learned about adjectives. So just like in languages, in spoken natural languages, in computer languages, there are names for things. And one of the names for a certain type of thing is everything enclosed in between this quotation mark and this quotation mark over here is called a string. I can't tell you why, it just is. The same way that a noun is a noun, an adjective is an adjective, a string is a string. And the way we recognize string is that it's encased in quotation marks, right? So what if I wanted to print a different string? So I've got print, and then I've got quotation marks. Hello. I'm going to leave space for someone's name. Thanks for coming. So who wants to put their name in here? Anybody? Let's do Jillian, raising her hand all politely. So again, let's run it. So we've got hello world, right? And we've got hello Jillian, thanks for coming. Hello Jillian, thanks for coming. So what this is a function, that's another word, right? Like nouns and adjectives. we've got a string and a function. And this function, what this function does for us is print whatever string it is we put between quotation marks. I could change this to anything and it would print it, right? Boom, it printed exactly what I typed out. I couldn't even probably do that again if I wanted those exact same letters, but cool. So we've learned what a string is, and we've learned what a function is. And we've learned how to print to the screen. I will mention right now too, everything I'm doing right now is part of a handout that is available at the libraries and digitally. So just ask your librarian and they'll get you a copy. So I've printed someone's name, I've printed strings, but sometimes we don't know exactly what it is we want to print, right? We might know we need to print something. We need to print somebody's name, but we don't know what the name is. So what this does is it's going to print the string hello with a space and then some name and then thanks for coming. If we ran this right now, let's see what happens. We're going to get an error. It says name is not defined, right? So we're looking for the value of name and we haven't given it a value. So this is what's called a variable. This is another noun is a noun, a string is a string, a variable is a variable. It's called a variable because it could change, it could vary. We don't know the value when we're writing the program, we just know we're going to need to know it, if that makes sense. So I'm gonna put my own name. I'm gonna thank myself for coming to my own program. I'm gonna run the program. And now we see, hello, Cole, thanks for coming, right? It used to be, go away, go away. It used to be an error, it said name was undefined. But here we have a whole name because I put my name in the variable. We could change it. Jillian. Boom. Rachel. Boom. You see, if I change it here, if I vary the variable, it prints out the same thing. Whoop. So this is what's called a hard coded, right? Every time I run this, it's going to, if I leave this and send it to someone and they ran it, it would definitely print Stephanie because I wrote Stephanie here and that's the program. But sometimes you want the user to say, hey, sometimes you need information from the user, right? Hey, give me your name. So I'll show you real quick how to do this. I don't want to get too deep into it. I just kind of want to show you what it looks like. So if you're doing this at home later, working through this, you'll get it to work. So the way you get the name is another function called input, and you type out the question you want. What is your name? And now when we run this, let's see what happens. Let's say Rocco. So hello, Rocco. Thanks for coming. So what happened here? We called this function input. It's and what it does, it's similar to print, right? It printed everything in this string to the screen, but then it waited for me to put a name in. So I could put any name here, right? Nate, Porter, Mohammed, any name. And it will print the name out reliably. So far we've learned what a string is, how to print to the screen, how to get input from the person using the program, and how to store that input in a variable. So these are very basic, introductory concepts to grasp that I'm hoping you're picking up. So the next question is, sometimes let's say you're in a class, right? And your teacher wants to write a program that keeps track of everyone's grade on a test or something, an assignment. So you need a list of names. So how do I store a list? So let me show you something real quick. Just gonna copy this in here. Just move this down a little bit. So here's some new stuff. Instead of a string, what we've got here is a new variable called names. Names, right? Because it's going to be a list of names. And here I've just made an empty list. And this is another sort of noun is a noun, verb is a verb. In Python, lists start with square brackets, which are close to the return key on a physical keyboard if you're hunting for them. But this list is empty, and I'll prove it to you. Watch this when I run it. List has 0 names in it, right? Print list. I'll talk about this in a second. But we have an empty list. So let me put 5 names in the list. So this is how we do that, right? And let's see how this runs. So what is my name? Cole. I'm just going to use my family's name. So Cole, Laura, me, Jimmy, Tom. Boom. Oh, and then I need this line. Sorry. Okay, so we start with an empty list. Cole, me, Laura. And I just put 5 names in it, and it says so, right? So if we go back to the code we wrote, we have an empty list. First, we printed that it has a number, and this is how we got the number, right? So this is a short function, len for length. So they're telling me to get the length or get how many things, count how many things are in this list and tell me how many there are. That's what this part does. And then because we're dealing with strings, we need it to become a string. And that's a little more complicated than I want to get to, but suffice to say, this is what you need to do to make this whole line work the way we want it to. And you can just add strings together like we've done. See this plus sign? So in order for that to work, it has to be a string. And then this is how we convert this number to a string. A little complicated, don't worry about it. This is a quick loop. And this is kind of intuitive, and also why Python is used for people learning programming, right? You can pretty much read this in normal English. While, and we already established up here, this returns how many items are in this list. So while the number of items in this list is less than 5, we've seen this before, get someone's name, and then we have another function called append. So we've got names here, which is the empty list right now. When we get a name, append or add to the very end, right? Append the name we just got. So what this part does is, while there are 5 or fewer names in the list, get someone's name, add it to the list. That's all it does. And then the very last thing we do is print. Super straightforward. Boom. 5 names. Any questions so far? Okay. So now that we have stored all the names, we need to see all the names. And how do we do that? Well, what we could do is print them out one by one, which would mean typing something like print names, I'll explain what all this means later, but you know, there's 5 things, right? So we have to do this, print names 2, print names 3, 4, 5, on and on and on. What if there were 100 names? That'd be very hard to type all that out, keeping track of whose name is what. So programmers designing these languages have figured out a very simple way, at least simple to read way, to see all the names in this list. And this is what that code looks like. It's called a for loop. So the way you read this line in English, right, is for each variable name in the list of names called names, print out the name. And it might seem strange, but it's just, if you think of it in terms of for each, so for each name in the list of names, do something with name. Right? So I need to, in order for this to work, I'll just delete this real quick. So let's do some names. Shaggy, Scooby, Velma, Fred. Oh, I don't know. Monster. I forgot the other people. So let's look at this output here. I can pull this up, I think. So we ran the program, and we've seen this before, right? There's 0 names. Then there were 5 names, which I put in. But then let me pull this down. Whoop. So here's the part right here that corresponds to this for loop here, right? So we put 5 names in it, and we see 1, 2, 3, 4, 5 lines where we've printed hello and one of the names. And if we look, we printed them in the order we put them in, right? Shaggy, Shaggy, Scooby, Scooby, Velma, Velma, Fred, Fred, Monster, Monster. So that's a way if you want to get all of the names from the list printed to the screen or do something with them, right? Imagine this was a number and you wanted to add it to a big sum. You could do that pretty easily with a for each loop like this. But that's more than I wanted to get into today. That's something for you to practice at home. And the last little bit of this demonstration that I want to get into, I want to show you how to print just one name, right? Let's say from the example earlier with a teacher who's grading a test, let's say she makes a list of names and their test scores, but she figures out she needs to correct Bobby's grade and make it bigger because she made a mistake in grading, right? That happens sometimes. So she needs to be able to get to just Bobby's name and not all of the names, right? Not everyone got the same score or the same score as Bobby. So we need to just change Bobby's score. That's a quick example. I want to start with a new list. You might recognize some of these names. And let's run this and just show you what happens. So I've got a new list, still called names, but I put different names in it. And this is a different way of getting names in, right? If you know ahead of time the things that are going to go in the list, you can just write it. So this is a list. See, it starts with the square bracket, ends with the square bracket. And then we have strings, which are the names, which we've been doing this whole time, separated by a comma. Now, sometimes they just put them on different lines because it's easier to read. This would work the same if we put them all on the same line. See, it made no difference. But it's just easier to see, oh, one thing per line, 5 lines, got it. You can see here. So how do I print just the first name in this list? Thor. So I'm going to introduce a new thing. I touched on it briefly. but we've done this much before, right? We've printed a string and added it to another string. And we get the whole thing. So because names is a list and there's 5 things in it, right? This is how the square brackets are how you get to the things in the list. And the number inside the bracket is called an index. So another noun is a noun, verb is a verb, an index is an index. And what an index does is keep track of which position in the list things are. So let's see what happens, right? We're trying to print the first name and we put a 1 here. So this is telling us print the first name is this string here and the first name in the list. Let's see what happens. Okay, the list has 5 names in it and it's telling me the first name is Iron Man. But we see here, Iron Man is not the first one, right? We were expecting Thor, but we got Iron Man. Well, why is that? We have a little puzzle to solve now. And this is very common in computer programming because sometimes you don't get the answer you were expecting and you have to figure out why. You know what you want. I know I wanted Thor, but we got Iron Man. So let's keep track of some things here. So we printed out what we thought was name number 1, but it told us the first name was Iron Man. So let's write here. Let's see what happens when we print out the second name. What's it gonna say? If you said to yourself, Captain Marvel, you were correct. So here we have Captain Marvel. I bet you can guess what happens when we put a 3 in here, right? We're gonna get Scarlet Witch, right? And then Spider-Man is gonna be 4. And I'll prove it to you, but I bet you believe it too right now before I run this. Spider-Man is number 4. Never mind the first name part. That's not going to change. But what we're trying to change is which name prints out. So we've identified that if we put a 1 in here, we get Iron Man. If we put a 2, Captain Marvel, and so on and so on. So let's count backwards. If Spider-Man is 4, Scarlet Witch is 3, Captain Marvel's 2, Iron Man is 1, Thor is going to be 0. And I'll prove it to you right now. So we got Thor, right? So that is sort of the end of the Python demonstration. And it covered a lot. We covered strings, we covered variables, we covered printing to the screen, we covered getting input from the user, we covered lists, how to print all of the lists, or how to print just one name of the list. And remember, we call this 0 indexing, right? We just figured out that if we tried to put a 1 in here, we got the second thing. So with lists, we start counting from 0. It's just a computer nerd thing. I don't know why we do it. We just do. But the phrase for this is 0 indexing because the first index is 0, obviously. And that is the end of the Python demonstration. Are there any questions? Okay. Well, that was the activity I had planned for here. The libraries have prepared these take-home kits with a bookmark, a bookmark making activity that has more information about the James Webb Space Telescope and the life cycle of very large stars. So I think it's worth picking up one. And for those of you watching in the future, hello from the past. But yeah, the libraries have kits. If you want to go pick them up, just coordinate with your librarians. So that's the end of this presentation. Are there any questions about any part of the presentation anyone has? I hope I covered everything to everyone's satisfaction. I want to thank you all for being here. Yeah, this went really smoothly, and I'm glad so many people came. So here's some more information about James Webb Space Telescope. You can find it at jwst.nasa.gov. And of course, NASA has a YouTube channel. They're all on every social media, Twitter, Instagram, YouTube, whatever you want. I'm sure they have a TikTok now even. I'm sure you can find more information all over the internet. Google or DuckDuckGo or Bing or whatever you like to use is your best friend here. And please keep learning about space and science and coming to things like this. Supporting your library is supporting NASA. So as I said, that's the end of my presentation. Thank you all so much. Thanks everyone who participated in putting this together. I'm going to turn this over now to Carrie Liston, who is working with NASA, who wants to get a little feedback from you all about this program just for data collection purposes. So I'm gonna go ahead and turn it over to her, and thank you very much.
Hi there. Thank you, Cole. That was awesome. I learned a lot. And thank you for sharing information about the survey. And actually, if you keep that up for just a second, I'm
Sure.
guessing people need another minute to
Oh, yeah.
access that survey.
Here we
So
go.
this is just a really short, anonymous,
Here we go.
like very brief feedback form for attendees. And if you have a mobile phone, you can aim it at the QR code, that black and white square. And if you click on it, it should show a URL on your screen. So that's a shortcut way to get to the online survey. And if that